The client SHCC, Société Hôtelière Camille Claudel, decided in 2007 to develop a low-energy hotel using the label All Seasons. The hotel was used as a pilot project for the development of an environmental approach designed specifically for this type of hotel within the group Accor. The design team consisted of the architects Espace Concept, the green building specialist Tao, and the HVAC specialist Cefern. The project consisted in the construction of an all-seasons hotel with 77 bedrooms situated in Troyes in the country France. The net gross floor area is 3,865 metres squared. The site, which was once an industrial site, is situated near a branch of the River Seine. A detailed analysis of the site in terms of pollution was carried out in 2002. The soil was found to be polluted with the following elements: chromium, copper and lead. Thus, the first step in the environmental approach applied to the project was to remove and treat the polluted soils during the excavation stage. The French green building system, Haute Qualité Environnementale, or High Environmental Quality Approach, consists in the application of 14 environmental categories to the design and construction of a building. The 14 categories range from management of the project to energy usage to the health and well-being of the occupants. The following environmental profile was defined by Terrao in accordance with the wishes of the client. The levels shown here correspond to B, where B is equal to basic, P corresponds to good, and TP is equal to very good. The categories that were treated with the level very good are the following: construction site impacts, energy usage, water and maintenance. The site is relatively open to the south, allowing the building to benefit from solar heat. The site is exposed to the sun for an average of 1,771 hours per year and receives 1,300 kilowatt hours per metre squared per year of solar energy on a horizontal surface. The internal layout of the building is designed to optimise the comfort of the occupants and reduce energy usage. The reception, bar and restaurant can be found on the ground floor. The main entrance is situated on the northwest facade and protected from the dominating wind from the southwest. The main entrance doors are accompanied with a SAS to avoid uncontrolled airflow, hot or cold, into the building. The bar and restaurant, which are only used in the morning for breakfast, are orientated towards the east, are connected to an outside terrace and benefit from the morning's solar rays. The rooms are located on the southeast and southwestern facades. Potential overheating is avoided by the use of automatic solar protections in the bedrooms. During the summer season, when a client leaves the room, the solar protections close automatically. During the winter months, the solar protections open automatically once the client leaves the room to benefit from the solar energy. The terrace, which is beside the river, is surrounded by a small microclimate, contributing to the reduction in temperatures during the summer period. Taking into account the two existing hotels in proximity to the construction site, the priority was to reduce the construction site impacts, notably in terms of visual and acoustic impacts. The following elements were put in place to respect this objective: a construction site waste management plan. A site waste management plan was put in place. This included the segregation of waste into skips adapted according to the type of waste produced. Each skip was marked clearly with the type of waste it contained to facilitate this segregation. 100% of waste was accounted for, and the amount of waste going to the landfill was reduced by the reusing or the recycling of the material. Cleanliness on site and reduction of pollution. The delivery area was covered with a layer of 30 centimetres of aggregates in order to limit mud and debris on the roads around the site. Biodegradable oils were used on site to limit pollution. Aesthetic fencing was placed around the site to reduce the visual impact. As you can see from the graph, the climate in Troyes varies between the winter and the summer. The winter period is from the 15th of October to the 15th of April, while the summer period goes from the 1st of June to the 30th of September. Terrao used thermodynamic simulation to optimize the conception of the building in order to reduce energy needs while ensuring a high quality of comfort for the occupants. The main characteristics of the building are as follows. 16 centimetres external insulation was used, and advanced window technology with an UW of 1.7 watt per metre squared Kelvin, gave an overall U value for the building of 0.407 watt per metre squared Kelvin. Heat recovery AHU is used for common spaces. In bedrooms, extraction of polluted air is automatically modulated by humidity. Ventilation is used only when the rooms are occupied, which reduces energy losses in the building, thus reducing heating demands. In summer, a BMS system closes solar protections when occupants are not present. BMS also manages artificial lighting in the entrance hall with daylight centres. LED technology is used to light corridors. A closed-loop water loop heat pump system meets simultaneously heating and cooling needs with high efficiency, which is especially interesting in a hotel. Over 45% of hot water needs are covered by solar panels installed on the roof of the building. The remainder of hot water needs are produced by a condensing boiler. The thermodynamic simulation was used to reduce cooling demand. Interior solar protections were found not to be effective. However, exterior solar protections prevent solar energy entering to the building, thus reducing the cooling needs. This hotel has applied for the French energy efficiency label HQE Environmental BBC, currently the most stringent in the country. Using the French national calculation methodology, or RT 2005, the energy consumption for the heating, cooling, hot water, ventilation, lighting and auxiliaries was estimated at 110.7 kilowatt-hours per metre squared per year in primary energy. This is over 50% less than the required energy consumption level. For the heating demand, the amount is estimated at 37 kilowatt-hours per metre squared per year in primary energy, and the cooling demand is estimated at 7 kilowatt-hours per metre squared per year in primary energy. In order to reduce water consumption in the hotel, the following equipment was put in place. High-performing, low-water use equipment. Water pressure was limited to 3 bar. Water-efficient toilets with dual flush 3 6 litres. Flow restrictors. Low-flow shower heads. A rainwater recovery system was installed to ensure all water needs for outside spaces and also to provide water to the toilets. A 20-metre cubed tank was put in place to recover the rainwater. The green roof and green spaces allow the reduction of impermeable surfaces.